Hello guys, today this video is about force on a current carrying conductor in magnetic field. So let's start the video and get into the concept. Force on current carrying conductor. Force on current carrying conductor. चल जा भाई चल जा, क्या हो गया, चल जा चल जा चल जा. Current carrying conductor. Okay, so this is the topic which we are going to deal today. Okay, so let us first discuss what is happening over here. So basically, when we have a current carrying wire over here, let's say we have a current carrying wire which is something like this. Okay, a current I is flowing in this wire in upward direction, and let us assume that in this area, in this zone, we have a magnetic field. And magnetic field is in which direction? In right direction. If you want to talk in terms of coordinate system, then current is flowing along y-axis and magnetic field is along x-axis. Magnetic field is along x-axis and current is flowing in y-axis. Now over here, as soon as the current starts to flow, it experiences a force. It will experience a force. This magnetic field which I am showing with the yellow highlighter, this is not the magnetic field because of this current carrying wire. This is a magnetic field which we have externally applied by something else, by some other magnet. So when these two magnetic fields, the one which we are applying externally and the one which is produced because of this current carrying wire will interact, when these two magnetic field will interact, then because of that this wire will experience a force. Now let us see what is the formula regarding this. The formula regarding this force is simply current, the magnitude of current multiplied by L cross B, magnitude of current multiplied by L cross B. Now to understand this formula properly, you should understand cross product. This multiplication sign which I have used over here, this is not normal multiplication. This multiplication sign which I have used over here, it is basically cross product. It is a type of multiplication which is done for vector quantities. If you see carefully, I have put arrows over here. What is the meaning of this? That this L as well as this B, these are vector quantities. Now to understand this formula properly and to use this formula, we need to understand how this cross product works. Now the magnitude of cross product, so let us first hold on this part and let us come to the cross product discussion, then we will again continue this part. Let us discuss a little about cross product. So over here, let's assume that I have two vectors. This is my vector A and this is my vector B. Now if I have two vector quantities and if I want to do cross product between them, A cross B, I am doing A cross product with B, then the magnitude of cross product, then the magnitude of this product, the magnitude of this product will be given by magnitude of A multiplied by magnitude of B multiplied by sine of angle between them. Magnitude of A multiplied by magnitude of B multiplied by sine of angle between them. What is the angle between them? The angle between them will be this angle. It will be this angle. Okay, it can be like, if you see the diagram, it looks as if it is somewhere around 45 degree. Okay, somewhere around 45 degree, okay, but it can be anything. Whatever the angle is there between these two vectors, you have to take sine of that, okay, you have to take sine of that angle, and then you have to multiply with the magnitudes of A and B. Okay, so this will give you the magnitude part of the answer, but the answer will not only have magnitude, the answer will also have direction, because this product will give me a result. This product will give me a result which will be a vector quantity, So over here I will not only get the magnitude, I will also get a direction. Now to find out the direction, we will be using right hand thumb rule. सीधा हाथ के अंगूठे वाला नियम, right hand thumb rule. Now to explain this right hand thumb rule just by using the screen is a little difficult, so let us go and check out a video, and then we will come back over here and we will continue this video. So 3, 2, 1, go.
Hello guys, how are you? This is my aviator look. I hope you like this look. Okay, so over here we are going to discuss about how to find out direction of cross product. So I'll be using these two markers to explain how to find out direction of cross product. Okay, so what I will do over here is I will consider this black marker as my first vector. I will consider this black marker as my first vector and this blue marker as my second vector. So let's consider that my first vector is in left direction. The first vector is in left direction. From your side it is in left direction, okay, and my blue vector is upwards, or the second vector is upwards. First vector is in this direction and second vector is in upward direction, okay. So what we have to do is we have to take our right hand and put the fingers of this right hand in the direction of first vector, and then we have to curl them towards the second vector. Now if I put my fingers in along the first vector and if I curl them towards the second vector, my thumb will give me the direction of cross product. So in this case the direction of cross product is coming inside the screen. Let us take one more example. So this time I will take my first vector in upward direction, okay, and second vector I am taking in right direction. My first vector is in upward direction and the second vector is in right direction. So if I put my fingers in upward direction, if I curl them, I have put my fingers in the upward direction and I am curling them towards the second vector. This is my first vector, this is my second vector. So if I put my fingers along the first vector and if I curl them towards the second vector, this thumb will give me the direction of cross product. This time again I am getting the direction inwards. Check it out. Now let us make it opposite. My first vector is in right direction. This time my first vector is in right direction and blue marker, the second vector, is in upward direction. So now if I put my fingers along the first vector and curl them towards the second vector, which is the blue marker, the thumb is pointing outwards. So now the cross product direction is outward. Let's take one more example. Let's say my first vector is in this direction, okay, and this is the second vector. This time they are not perpendicular to each other, okay. They need not be perpendicular to each other, right? So this time they are not perpendicular to each other. So this is my first vector, and this is my second vector. Again same rule, put your fingers of right hand in the first vector direction, curl them towards second vector. The thumb will give you the direction of cross product. The thumb will give you the direction of cross product. So this time the direction is towards you. This time the direction is towards you. One last example. Please check it carefully. Last example. This is the first vector. This time the first vector is towards you. The first vector is towards you. Okay. And second vector I am taking in the right direction. Second vector I am taking in the right direction. So if I curl my fingers in the direction of right, first you have to put the fingers along the first vector, then curl them towards the second vector. This time thumb is pointing upwards, so direction of cross product this time is upwards. Are you getting it? So basically I will just repeat it once more. What you have to do is you have to take the right hand. Please remember this, do not take your left hand. This is right hand thumb rule. Okay, so you have to take the right hand, then you have to put the fingers along the first vector. You have to put the finger along the first vector, and then you have to curl them in the direction of second vector, and thumb will give you the direction of cross product. Thumb will give you the direction of cross product. So thank you guys. This is all for the direction of cross product. Let's go back to the main video. Bye bye. See you there.
I hope now you have understood how to take cross product, how to do cross product, how to find out the magnitude of cross product, as well as how to find the direction of cross product, and I really hope that you enjoyed that part. Okay, so let's continue with our main discussion, which is force on a current carrying conductor. Force on a current carrying conductor. So the formula which we have seen over here is current magnitude multiplied by L cross B. So this I over here, as I have already said, is current. This I over here is current. This B over here is magnetic field. This B over here is magnetic field. Magnetic field. Now what is this L? What is this L? So if I take a current carrying conductor, it will have some length, right? This L represents that length. This L represents that length. Okay, so it is basically length of the length of the conductor. My spellings are horrible. Okay, so this is the length of the conductor. Now if you see carefully, this length I have represented as a vector quantity. This length I have represented as a vector quantity. So to find out the magnitude, it is not difficult. You can simply calculate what is the length of the wire, and that will be the magnitude. But how will you define a direction for this length? So to define the direction of this length, we will use the direction of the current. Okay, so this part is very important. To define the direction, to define the direction, use direction of current. Ooh la la. Okay, so to define the direction of length, you will use the direction of current. I feel like a rapper, huh? To define the direction of current, use the direction of current, huh? To define the direction, use the direction of current. Okay, so let's come here and take this example. Over here the current is flowing in upward direction. If current is flowing in upward direction, what I will do is I will take the direction of L. I will take the direction of L as upwards. I will take the direction of L as upwards. As simple as that. As simple as that. Okay, nothing fancy, nothing difficult. Okay, so like this you can figure out the force on the current carrying conductor. By using this formula, you can figure out the force on a current carrying conductor. Okay, now in 10th class, no one will expect you to actually calculate this formula, but still we will look into some basic questions and basic situations so that we get a proper feel of this. Okay, so first situation which we will see over here will be when the length of the current carrying wire and magnetic field B are parallel to each other. So first case which I will take over here for you guys, case 1. So case 1 which I am taking is when length is parallel to magnetic field. When length is parallel to magnetic field. Now if my wire which I have kept is like this, where the current is flowing in this direction, and let us assume that the magnetic field is also in this same direction. The magnetic field also is in this same direction. So if you see carefully, current as well as magnetic field both are along x-axis. Current as well as magnetic field both are along x-axis. If both are along x-axis, it means they are parallel. It means they are parallel, right? And if they are parallel, what will be the angle between them? Angle between them will be 0. Check it out, check it out. Both are parallel. So what is the angle? 0, right? If both would have been perpendicular, then what would have been the angle? 90 degree. If it comes like this, it will become 45 degree. Now if it becomes totally like this, then what will be the angle? 0 degree, right? So I hope you have got the feel how it is 0 degree. Okay, so if they are parallel to each other, the angle between L and B is basically 0 degree. The angle between them is 0 degree. The angle between them is 0 degree. Okay, now let us write down the formula. What is the formula for the force? I am only writing the magnitude part. Okay, I am only writing the magnitude part. If I write the magnitude part, it will become L cross B. L cross B magnitude was what? LB sine theta. LB sine theta. So this is basically the magnitude of force. This is basically the magnitude of force, I multiplied by magnitude of L cross B, which is LB sine theta. Now what is the value of sine 0 degree? Sine 0 degree is 0. Sine 0 degree is 0. So what will be the value of force? The value of force will become 0. The value of force will become 0. The value of force will become 0. Okay. So in case when length and B are parallel, or I can say when current and B are parallel, the force on the wire will be 0. The wire will not experience any force. Now this is very important. If I keep a current carrying wire in a magnetic field, is it guaranteed that it will experience force? No, it is not guaranteed. If it is kept parallel to the magnetic field, then it will experience no force. It will experience no force, 0 force. Okay. Now let's see one more condition. Let's see one more condition. Case 2. In case 2, I will take magnetic field as well as the current perpendicular to each other. So if my current is flowing like this, my magnetic field is somewhere like this. The situation which I have taken in this is the same situation which I have taken in the starting. The same situation I am taking. Okay. So over here if you see carefully, the angle between magnetic field and current, is actually 90 degree. The angle between magnetic field and current is actually 90 degree. Okay. So the magnitude of the force will become what? The magnitude of the force will become current multiplied by L into B multiplied by sine 90 degree. What is sine 90 degree? 1. So the force value will come out to be BIL. Simply BIL. This is the value of force. Okay. So in case if current and magnetic field are parallel, the force comes out to be 0. In case when they are perpendicular to each other, the force will come out to be BIL. These are the two special cases which, if you know, you will get a lot of confidence. Okay. For any other case, actually, see, if you understand how to put the values in the formula, then you can find out any force. You can find out force for any situation. It is not a big deal. Okay. Now there is one more aspect of the force, which is direction. Now in first case, there is no need to find out any direction because the force is coming out to be 0. So 0 will have no direction. Okay. 0 will not have any direction, right? excuse me. But in the second case, I am getting a force BIL. Now over here I will have direction as well, right? And how will I find direction? Direction I will find using right hand thumb rule, which we have already seen in the video. Okay, which we have already seen in the video. So what you have to do is, you just have to put your fingers along the first vector. Over here, what was the first vector? L cross B. First vector is L. The basic formula, recall the basic formula. The basic formula was F is equals to current multiplied by L cross B. L cross B. So first vector is L and second vector is B. First vector is L and second vector is B. In this case, what is the direction of L? Direction of L is Y direction, Y, in the direction of Y, and B is in the direction of X. So you have to keep your fingers along Y axis. Then you have to curl those fingers along X axis or towards the X axis. The thumb will point towards the direction of force. The thumb will point towards the direction of force. So in this case, in this particular case, the direction of force will be downwards or inside the screen. The force over here, the direction of this force, will be inside the screen. This is the symbol for inside. Okay, this is the symbol for inside the screen. Whenever we want to show inside symbol, whenever we want to explain this term inside in 2D, we draw it like this. This is how we draw it. If I want to explain outside direction in 2D, then instead of cross I will put a dot. That circle will be there, okay, but instead of cross I will put a dot. Over here the force is inside, L cross B, and please do not use your left hand, always use the right hand. Okay, so if you put your fingers along the current and curl them towards B, please try it. Okay, you can all please give it a try. Okay, if you put your fingers along the current and curl them towards B, the thumb will point towards the direction of the force. The thumb will point towards the direction of the force. Multiplying it with current magnitude will not affect the direction. It will only affect the magnitude of the force. It will not affect the direction of the force. So only by doing cross product between L cross B we can find out the direction of the force. Only by doing cross product between L and B we can find out the direction of the force. And in this situation, in this particular situation, the direction of force is coming inside the screen. The direction of force is coming inside the screen. Now next topic which I am going to discuss over here is Fleming's left hand rule. Now before starting Fleming's left hand rule, I want to clarify one thing. First of all, I never use this rule. Second, I want you also to never use this rule. Okay, I also never use this rule, and you should also try to avoid using this rule. This rule might sound or might look a little easier to you right now, but trust me, it is not. Trust me. Okay, but still it is given in the course, so we'll be going to discuss that. Okay, and it can be asked in the exams as well. Okay, so let's start with the next point. Let's start with the next topic, which is Fleming's left hand rule. Left hand rule. Fleming's left hand rule. Okay, now according to Fleming's left hand rule, what we have to do is we have to first put our index finger and the middle finger and the thumb mutually perpendicular to each other. We have to put the three fingers, the thumb, the index finger or the forefinger and this middle finger mutually perpendicular to each other. Thumb, forefinger and middle finger we have to put mutually perpendicular to each other. Now after putting them mutually perpendicular to each other, we have to assign the quantities to these. Now thumb will be my force. Thumb will signify force, or thumb will represent force over here. Okay, thumb is representing what? Force over here. My forefinger will represent magnetic field. My forefinger, this forefinger will represent magnetic field. My forefinger will represent magnetic field, and my middle finger will represent current. Now after putting these three mutually perpendicular to each other, you just have to point forefinger and middle finger according to the direction of magnetic field and current. The direction of thumb will give you the direction of force. This is how you have to use Fleming's left hand rule. And one more thing guys, as the name suggests, you have to use only your left hand. Do not try to use this rule using right hand. Okay, I know it's not that straightforward, it's not that easy to understand it just by looking on the screen. Okay, so let's again go back to another video and let's check out how to utilize this Fleming's left hand rule. So 1, 2, 3, go!
Welcome back guys, welcome back. So this is the second time we are meeting in the same day. Okay, so what a nice day guys, what a nice day. Okay, so in this video I'm going to tell you how to use your left hand Fleming's rule. How to use left hand Fleming's rule or Fleming's left hand rule. Okay, so first thing which you have to remember is that there are things assigned to these three things. Okay, the thumb, the forefinger and the index fingers. So there are concepts which are assigned to these. This is my force, this is my force, F. This is my force, thumb is force. This is my magnetic field, FMC, force, magnetic field and current, FMC, force, magnetic field and current. So first of all you have to remember that this is for force, thumb is for force, this your forefinger is for magnetic field, and this middle finger, I will not show you of course, but this middle finger is for current. This middle finger is for current. Okay, so my thumb is force, this index finger is for magnetic field, and this middle finger is for current. This middle finger is for current. Okay, so what you have to do is first you have to keep all these three mutually perpendicular to each other. So this is how you have to keep it. Check it out. Right now this middle finger is pointing towards left, your left. This index finger, this forefinger is pointing towards you, and this thumb is pointing upwards. So all these three are mutually perpendicular. Check it out. All these three are mutually perpendicular, and do not take your right hand. This time you have to take your left hand. This is Fleming's left hand rule. So you have to keep them in such a way that all the three are mutually perpendicular to each other. Are you getting it? So now after you have understood this, then it is not at all difficult. What you have to do is, let's say your current is flowing upwards, so you have to keep your middle finger up. This is for force, magnetic field, current. So if current is upwards, you have to keep your middle finger upwards. Okay, you have to keep your middle fingers finger upwards. Let's say the magnetic field is left side. Let's say the magnetic field is left side. So middle finger is up. Magnetic field is left side. Magnetic field is left side. Now where is this thumb pointing? Towards you. Towards you, outside the screen. The thumb is pointing outside the screen. It means that if my current is flowing upwards and if the magnetic field is in this direction, then force will be applied in this direction. Force will be applied in this direction. Let's say this time my current is flowing inside. My current is flowing inside the screen. The current is flowing inside the screen. Magnetic field, let's say, is still in the left. It's still in the left direction. Your left direction. Magnetic field is still in the left direction. Current is flowing inside the screen. Now this time thumb is pointing upwards. It means that the current carrying conductor will experience a force in upward direction. This is how you can use Fleming's left hand rule, but this is my suggestion to you guys that don't use this. Okay, just understand it, but don't use it. Try to use the other rule. Which one? Right hand thumb rule. The right hand thumb rule. Okay, that one is much easier to understand, and in the later classes, in the 12th class, that will be more useful. In the 12th class you won't be able to use this Fleming's left hand rule properly, okay, because the situations will be a little complicated over there. So it is better if you practice right hand thumb rule in finding out the cross products, direction. Okay, so this is my suggestion to you guys. Okay, so I hope you have enjoyed this. I hope you have understood how to use Fleming's left hand rule. Bye bye guys, bye bye.